This is a 24-inch Blaupunkt television set from the 70s, I believe. This is a hybrid TV. I bought this thing on Facebook for 20 euros and the guy said it didn't work. The guy said it didn't work, and usually around here when people say that a TV doesn't work, it means that they plugged it into the mains. There was no raster, because if people see TV displaying a raster, they say that it works, because they don't know how to display a picture or plug in a modulator, etc. to this old television. So by a TV working, they mean that it is able to display a raster. So this doesn't have a raster. The guy was asking for 30 euros. I offered him 20 and he said take it, and I bought it. This uses a A61 120W CRT. The 61 means that it's 61 centimeters diagonal, and these late model black and white rectangulars with the 120W model number, these are very reliable. I have a couple of TVs with them and they always seem to test very good. I don't know about this one, but it's probably fine. And over here we have a Philips 1960s 23 tubes top of the line black and white TV. This is a really beautiful, great performing television. It's 23 tubes, no transistors. It has, I don't know, 12 or 13 diodes, all silicon diodes, no germanium stuff in there. Here is the CRT mask, and this is a 21TD 310A Leonardo Volt automatic, and this television is fully automatic hold controls, perfect black level self-adjusting. It has lots of cool features. A very complex circuit and hard to troubleshoot, but very reliable. And I bought this also for 50 euros from a lady that said that this was a low hours TV. Of course it was a lie. CRT was very tired. And over here is a CRT that comes on that model. And we can read here, this is Portuguese, and translated it says rebuilt kinescope. It was rebuilt by GE Portugal, General Electric Portuguese, in the 23rd 1980. So it was rebuilt in 1980. It's an A53 88W CRT. These are always very tired and bad, and what happened was I got another of those TVs in the house. I did a full-blown restoration, new electrolytics. It was working very well, perfectly. It was working perfectly with this CRT. When this thing went to air, it started developing a blue spot around here on the bottom part of the neck, occasional flashes and arcing, and it developed a problem where the white parts of the picture would go very white and the dark parts of the picture would go very dark. So it was like a turbocharged contrast control, or like a crazy AGC voltage, super overloaded. And I spent weeks, maybe months, troubleshooting the AGC section, because this TV has a very complex AGC system. It even has a cool feature in which they, in order to to reduce the heating hum, which means weird stuff on the screen and weird stuff on the speaker when the TV is warming. They rectify the voltage on one of the heaters, on the heater string. They rectify that voltage, they extract the negative part of that voltage, and they feed that into the tuner in order to block the tuner from working. Once the horizontal warms up and the boost voltage is developed, the boost voltage contradicts that negative voltage and the tuner starts working only after the horizontal is working. So lots of cool and complicated weird stuff on the circuitry of those nice televisions. So I spent lots and lots of hours trying to diagnose this thing. I asked for help on a German forum. I asked for help, I don't know, I asked everybody I could ask. Nobody seemed to know what the problem was, and the problem was just the CRT, nothing else. This reads no emission at all. It still displays the picture, but very weird picture. Maybe I'll put some pictures of that right now. So then I bought this, removed the CRT, put the CRT on the other restored TV. CRT is very weak, and it came with a brightener transformer, so I fitted both the CRT and the brightener on the other set, and it works very well. It displays a nice picture, but its days are counted. It's gonna die soon, and I just cannot find good CRTs of this vintage here. I can buy 10 televisions and they're always tired and bad, because here in Portugal we lived in a dictatorship until 1974, so people didn't have a lot of money to spend on television, so they really milked their television sets to the max. They used them and used them and used them until the picture tube went completely bonkers, and that's when they were tossed away into storage. So when you buy an old TV here, you are buying a TV with a dead CRT, that's for sure. So what I'm thinking here is that I tried wiring this TV back to back into one of these rectangular CRTs, and it works very well. The pinout is the same, the ratings are similar, the deflection angle is the same, and it actually displays a nice picture in one of these rectangulars with good linearity, full deflection, etc. So I'm thinking about fitting this rectangular CRT into there. I got here the mask. This is the mask for a rounded tube like that, 21 inches. And this is a 24 inches CRT rectangular. Of course, 24 inches means the diagonal, but since this is rectangular and has sharp corners, of course it's going to measure longer. If we put the mask on top of the CRT, you can see it is pretty much it. So I think with a little bit of trimming around here and making some brackets, I can fit this into that, and I can give that TV another 20 years of life. That would be really interesting. If you think that I'm doing something wrong here, that this is not correct, historically incorrect, or that I'm committing some sort of crime here, let me know in the comments. I'm going to try that. And why? Because this TV has no high voltage. I'm not afraid of gutting it because it doesn't develop any high voltage and probably has a bad flyback. I think it has a bad flyback. So this is a hinge chassis, fully loaded with these craptastic germanium transistors full of tin whiskers. Got their solid state IF, our tuner, really modern looking tuner, Japanese speaker, it's a Pioneer unit. Oh, and I don't have the schematic for this, I can't find it anywhere. I can't find schematics for any of the Blaupunkt sets that I managed to buy around here. So, okay. This is the audio output tube, audio output transformer. Really? Sorry about that. So, audio output tube, audio output transformer, vertical output transformer, vertical output tube. These are probably linearity controls. These black things are electrolytics. These are some type of plastic encased paper capacitors. These are shit. These are very good caps. I could probably take this out and use them to recap another TV or radio. These mustard ones are also amazingly reliable. Got our horizontal frequency adjustment. The slug is broken, slightly broken on the top. There's the chunk that's missing on the top. Here's our horizontal oscillator with my test socket adapter installed, our damper, horizontal output with the cap off, and we got here a solid state high voltage rectifier, rustificated completely. This little board is broken in half, but no traces have been affected because somebody has already soldered it and patched it. We have some dropping resistors, blah blah blah. So this thing has no horizontal. I'm just gonna do a quick troubleshooting on this just to rule out. I already swapped these 3 tubes, so it's not the tubes. I'm just gonna make a quick troubleshooting, check if the oscillator is running, check if the drive signal is reaching from the oscillator to the output tube. I have already tacked in a new boost capacitor on the bottom, that green thing right there, because the old one was exploded. Come on. There you go, see that crack? It's cracked open, completely exploded. So I tacked in a new one. When these things short, they load down the high voltage, and if you try to run the TV with a leaky boost capacitor, it probably will overheat the flyback and melt it. That was probably what happened on this thing. So I have the multimeter in the oscilloscope, just gonna check some DC voltages on the oscillator and the horizontal output. I'm going to check the drive from the oscillator to the horizontal output. If all seems good, it means we have a bad flyback probably, and it means that I'm going to advance with trying to put this into that. Right, so I turned it on. You can see the filaments glowing. I can kind of hear the 15 kilohertz whistle. It seems to be running, the oscillator seems to be running in the sort of a correct frequency, but the whistle is very faint, which kind of tells me that there is something loading it down, probably shorter turns on the flyback. I already measured continuity from cap to cap. The flyback's not open, and usually it's usually never open. Problem is generally shorter turns. So we have something on the speaker, but we have no sound. If I turn the volume up, okay, the audio amplifier is working because we have this crackling noise, but the IF is dead, and all of the transistorized section is dead, probably because the 12 volts or 15 volts or whatever it's needed to run these transistors is probably generated in the flyback itself. So all of the transistorized section is completely dead. And I'm not gonna bother to try and find a replacement flyback for this. It's really not a good, desirable television. It's just a crappy hybrid. So let's make some DC checks. Got here a schematic for a totally different TV, but it uses the same model oscillator, so we can use this as a guideline for the pinout of the tube and the different voltages. The same for the horizontal output. Okay, so we need to have DC voltage on pin 3. Is that a 6 or an 8? 3 and 8, I believe. Okay, so 1, 2, 3. Oh. Okay, so it's actually pin 3 and 6, and I had the meter on amps. I had the lead connected to amps, and I was actually short-circuiting this thing. I'm glad I didn't blow up the meter. Okay, so pin 3. We are on pin 3, 200 volts. Okay. Pin 6, 9, 8, 7, 6, 160. Okay. We seem to be good. Next, we might check this 200 volts on pin 7 of the horizontal output, or better yet, we're going to check on pin 1 for the presence of a negative voltage, and that will indicate if the tube is working. Okay, so pin 1, let's see if I don't short this thing. Yeah, negative 47 volts. So it appears that everything is fine, except that we don't have any high voltage. Okay, so I have the cap off. Let me put it. See there? You have a spark there, then it seems to load it down. Interesting. Okay, I'm pretty sure that we have a bad flyback, but just for fun, we're going to pull up the oscilloscope so that you can maybe, I don't know, maybe learn how to do it. Probably you know better than I do, but If you can learn something from me, that's cool. Okay, we have the oscilloscope on the plate of the oscillator in 6, and it goes into the grid of the horizontal output. We could probe here also. Maybe this resistor could be opened, probably not, otherwise we wouldn't measure this negative voltage. But anyway, we have the scope in here. We have this thing, an auto trigger, AC coupling. Our source is channel 2 because our probe is connected to channel 2. Here on the probe we have a ×1 and ×10 switch, and it's set to ×10. Here our mode switch is set to display the trace of channel 2. We have this thing on 50 volts per division. We have 5 volts here on the knob, ×10 of the probe. AC coupling. What else? Our frequency, or our time per division, is set at 20 microseconds. And if you don't know what that means, you can simply go to the internet and write like this: period to frequency calculator. And you have a calculator that converts this microseconds per division into hertz or cycles per second. So if we want to measure 15 kilohertz and we set the knob to 20 microseconds per division, it means that a full cycle of the waveform will occupy 3 and something squares. 3 squares and a little bit of the 4th square. So we'll see if that checks okay. This can be running at the wrong frequency, but it would still have to produce high voltage. Only if the frequency would be very wrong, it would probably load it down or produce very low high voltage. But if this thing is running at the approximate frequency it should be working, producing a raster, producing high voltage. Okay. So another thing, the oscilloscope is not grounded, the TV is not grounded, I don't have an isolation transformer, so nothing is grounded. We can use the oscilloscope on the TV, but with one word of advice: every single metal part of the scope, including these metal knobs and these BNC connections, they're all gonna be directly tied to the chassis of the TV. And since this is not a power transformer set, this is a series string with hot chassis, we need to set everything we want to set on the scope before we turn the device under test on, okay, because we don't want to get a zap. So here we go. There it is. There's our sawtooth waveform drive signal from the oscillator to the output. It seems completely correct and fine to me. I'm gonna check the frequency. So 1, 2, 3 and something square. So it's running at about 15 kilohertz, which is the right frequency it should be running. So yeah, probably we have a bad flyback, most likely. Let me unplug the TV. Okay, so this is me touching the grid of the horizontal output right there, and our drive signal is arriving there. So yeah, bad flyback. I'm gonna say it's a bad flyback. So we don't seem to have anything to lose by removing this CRT and trying to put. Okay, so I removed the horizontal output tube and I checked all the DC voltages there. They are present. They have a positive voltage here. When the tube starts conducting, it turns into negative voltage. You have DC voltage here. The cathode is connected to ground. The filaments are lighting because we see the tube glowing, so I really don't see what else can be wrong here. I have the cap of the rectifier disconnected just in case the rectifier would be arcing or something and loading down the high voltage. So there really is no way that this thing's gonna work. So I really think that the exploded boost capacitor just took care of the flyback, damaged it permanently. So we have nothing to lose with this shitty TV. We have a very good CRT, and we're going to proceed with trying to fit it on that cabinet. The mechanical part of the fitment doesn't bother me. I can make some brackets. The only thing that bothers me is that this CRT seems to have a sharper angle right here. This one seems to be more of a flat surface. So I'm concerned that the chassis might hit here. If the chassis hits the CRT surface, I'm going to have to make some spacers for the chassis, because the chassis is laid horizontally like this on both sides. Everything is very tightly packed. Remember that thing has 23 tubes. So okay, but that doesn't bother me. The electrical part also doesn't bother me because it's plug and play. The neck diameter is the same. I've already checked that, so the yoke will fit perfectly. And yeah, that's it. Let's see how it goes. Maybe in the next video I have this thing already fitted in that girl right there. So I have already removed the CRT from the Blaupunkt TV set, and it's now completely fitted and secure inside of the cabinet of the Philips TV. As you can see down there, I made some brackets using scrap metal that I had. I had a couple of these L-shaped brackets and I bent them, and they're very well secure onto the cabinet with some not very pretty screws, but hey, nobody will see that. There's the other. And on the top I used the original fixing rods. These rods press against the CRT strap and they kind of press the whole tube against the mask, and these ones support the weight into the bottom of the cabinet. So it's in place, it's secured. We have very little clearance from the speaker, but it's not a problem because I need to unbolt it and set it a little bit more to the right to center it properly. But for now I'm going to leave it like this. I'm going to fit the chassis, see if it displays a picture. Of course the TV needs a complete recap, new electrolytics, most likely. We have a small, little bit collapsed vertical, about 50% of deflection only. And the horizontal is also a little bit weak. I don't know if it's a weak horizontal output tube or what. And this was tested with the old original CRT that was in here. But I'm going to fit the chassis now and turn it on, see if everything works as expected. If it does, I'm going to remove this again, clean the faceplate and fine-tune its position, and proceed with recapping the chassis. I'm going to show you how it looks on the front. So you might not even notice anything here. First thing, the phosphor color is different. This is a gray, completely gray, and the original one was kind of a greenish tint. You can see here a little bit of the black area where the CRT ends, but that's not a problem because I need to put it a little bit onto that side, fine-tune its position. There is a little bit of a gap on the bottom and on the top, and also a tiny little gap on the sides, but nothing too visible, nothing that I'm too concerned about. These stains and dirt and crap that you see inside, they're all gonna be cleaned and removed if this thing works as I expect. So stay tuned. So I have the chassis reinstalled, kind of. The connector for the CRT actually crumbled apart, so I have the wires just twisted, kind of hanging around here in a very unsafe way. These are the speaker wires, doesn't matter right now, but you got here the control panel on the floor with this nice tar cross the line capacitor still in circuit. Hope it doesn't blow up in my face. And the chassis actually hits the CRT, but I have a solution for that. But first, before we talk about that, let's just see if this thing works at all. Okay, I have the plug in my hand. These TVs always, I don't know why, they always contain tubes that have this filament flash, really violent filament flash. But I never had problems with open filaments, so I guess that's normal. On the other set that I have in the house, I actually replaced all the snubbering capacitors on the heater chain, but that didn't cure the problem. It's really the tubes. Okay, I'm hearing the horizontal oscillator starting. This is the vertical. The vertical is really noisy on these Philips televisions. Okay, I have brightness and contrast are all the way up. I hear some arcing on the high voltage anode connection. Oh, look at that. Full deflection, nice brightness, nice contrast. The snow actually looks really soft, so I need to play with the focus. But yeah, this is really good, really good. I don't want to keep this thing running for any length of time because this thing is really dirty and rusty, so it's kind of arcing. I don't want to stress the flyback. These electrolytics are all crapped out, including these small ones. Some of them are, well, this one is actually broken. Some of them are melted. All of these yellow ones, these mustard capacitors, they are fine, but I'm concerned about the electrolytics. These small electrolytics metal, these metal cans with the yellow rubber thing on the bottom, they are always bad. They are very old, so wouldn't expect anything else. And the way that this thing is connected with the wires twisted, and I don't want to run this for any length of time. So that's it for this video. Meanwhile, what I'm going to do is I'm going to remove everything again, and I'm going to mount the CRT a little bit more to the front. And the way I'm planning on doing that is actually cutting a little bit of the mask to bring the mask up front a little bit. Maybe I can get 1.5 centimeters. I think that would be enough. I'm not the guy to take many measurements. I usually eyeball everything, so sometimes things don't go as planned. But I think that if I cut 1.5 centimeters all around and bring the mask a little bit to the front together with the CRT, the chassis, I think the chassis will fit. I may have to add some length to these rods, maybe cut them and weld a piece of metal to make them longer, because they are almost maxed out right now. I will also have to re-drill the bottom mounting points. That's no big deal. I'm happy. And I think I found a solution for these Philips televisions with the rounded CRTs that are always bad, because these rectangular black and white CRTs, they're plentifully available, and they seem to be always in good shape. So I'm happy. See you next time.